In this video, I start my introduction to business analytics. Business analytics is the backbone of decision-making. Managerial decision-making depends on information. I have a few examples here, like the type and quantities of products to sell or make in manufacturing, pricing of products at different times, facility location for service and manufacturing, moving the facility, expansion, downsizing. All these decisions depend on information analysis. Hiring, training, and retention of employees in an organization. Topics, areas of training, qualifications for hiring. These are the topics that require information analysis. Selecting and developing information systems for an organization, that's a costly decision and should be done carefully based on the information available. Marketing campaigns for niche markets and mass marketing. All different types of decision making depend on information today. So in a sense, business analytics is exploring organizational data systematically. We use statistical methods, mathematical methods, and computer software. Through this process, we transform data into information. The raw data is not usable. We have to transform it into information. We may summarize and visualize data in order to understand what is happening or what happened in the past. We may look for meaningful relationships between variables. Examples include sales and advertising, or seasonal variation of a parameter, for example, sales. Finding out what's the pattern of the change through a timeline, and then use this information to make predictions, forecasts for the future, or recommend solutions. Most of what we do in terms of keeping or generating the documents or storing information is by computers. All project developments and customer information and business correspondence, technical documents, design, and pretty much everything is stored in computers. So we use all this data in order to find the patterns of change or relationship, building predictive models, planning for the future operations. Now we'll look at the process of building a model, business analytics model. We often start from a question or challenge from the environment, what we do in our operations and what we understand from the environment. There's an opportunity or challenge. Well, based on that opportunity or challenge, we need to come up with some research questions, what we need to understand. Based on those questions, we must have a solid hypothesis. We have to start thinking about a statistical model to analyze the data and get useful information out of it. So we have to go after the data, select the proper data, which might be stored in spreadsheets, corporate databases, enterprise system, other external sources, including the government or other companies that process and store data. After selecting data, which may not be crafted to our needs, we need to select parts of the data that are required, query a database typically, filter the data, clean the data. If there's any error or missing elements of the data, we have to fix that, visualize the data to understand the basic patterns, summarize the data, build statistical models, and then put them all together to make a business analytics model. The statistical models we use include univariate, bivariate, and multivariate. In univariate models, we have just one variable. Typically, we summarize the data to understand this type of the distribution, graph the data, and have some summary statistics for basic understanding of the nature of the variable. In bivariate analysis, we look at the relationship between two variables. Typically, regression analysis, X and Y, relationship between two variables, contingency tables, relationship between two categorical variables, one-way analysis, and multivariate analysis that includes investigating simultaneous effects of multiple variables on one variable, like multiple regression. These are more complex methods. There are different approaches to data analysis. Exploratory data analysis is a method where we have a problem and data. We don't have any specific model in mind. We do some analysis, explore the data in order to find the proper model, and then we run the model, build the model, run the model, and make a conclusion out of it. In this method, our focus is on the data and finding good models. In classical approach of data analysis, we do have a problem in hand, we do have a data set, and we do have a model. For sure, we know that we are going to build a specific model. For example, if we do have two continuous variables, we know that we're going to run a regression analysis, so the model is known, and then we do the analysis and make a conclusion. There are other approaches as well for data analysis, and we will use some elements of different approaches to data analysis through this course. This is an example of univariate analysis, summary statistics, and distribution of one variable. We do have the histogram, box plot, understanding if we do have outliers or not, what's the shape of the distribution, all the quantiles, and summary statistics. So we understand the nature of the variable and distribution of the observations. Through visualization, we can understand the relationship of variables to some extent. For example, in this graph, we visualize the relationship of calories and total fat from candy bars file, and then we can see that there is a positive relationship between these two. And since we have two variables here, this is a bivariate analysis. Another example of bivariate analysis is regression analysis. The same relationship between calories and total fat. We can fit a regression line and then investigate the output and see how much of the variations of calories are explained by the total fat content of the candy bar, and if the model is significant and valid. To get some intelligence out of your business analytics, you have to follow a process. First, we have a target. We need to determine that target for the analysis. What we are going to do exactly with the data in hand, or the data we're planning to collect. So we need a hypothesis to start with. And we need to use our knowledge about the data and context of the business. Then we will decide about our approach. Is it exploratory data analysis or classical, or sometimes the mix of both? Make your study a practical statistical study. It means we do not include a very large data set or a very large number of variables into our model where we can't do the analysis or build a good model for that, or even don't have enough computer power to do the analysis. We need to find or collect proper data, refine and clean the data so that we have a manageable, clean data set. The variables we're going to analyze should be determined. We don't include too many variables into one model. You have to select the important variables and then build the model and solve it. Things you should remember from Introductory Statistics course include normal distribution. We'll use this frequently. Z-score and what it means. It's the distance from the mean of the distribution measured in standard deviations. Central limit theorem. I do have exercise file and a video for that in this module. What is a representative sample? Samples taken for any study should be representative of the population. We have a simple sample, which is randomly selected with no prior plan. We can have a stratified sample, which represents subgroups within the population. In this type of sampling, we try to represent different subgroups by proportions that represent the same proportions of the population. In systematic sampling, we follow some rules. For example, if you're going to sample products every 15 minutes or every 100 units out of the production line be sampled, we follow the rules. That will be a systematic sampling. Understanding the hypothesis testing is important. There's always a null and alternative hypothesis. Null hypothesis is typically about no difference between the groups or subgroups, or no effect of the factor. Alternative hypothesis is always trying to establish a difference or the significance of the effect of a variable on the model. And the p-values. P-values of statistical tests, always the small p-value of a test represents the significance of the test. We'll see this topic later in all our modules.